Okay, so we are going to use, we're going to talk about functions again, and we're going to talk about increasing, decreasing, and constant, where the functions are increasing, decreasing, or constant. So we're going to use the graph, and we're going to talk about it a few seconds about what it means for a function to increase and decrease first, though. So even though the graph looks like it's going up on both sides, which it is, there are certain parts of the graph where as you go along the graph, the actual y value is decreasing. And it would be up to here. Now this is the minimum point, or the vertex. In this particular part of the book, they call this a minima. And what that means on a function is that it is a point where the graph goes from decreasing to increasing. So this is what we call, and they call that a min, M-I-N. Okay, so that is where the graph goes from decreasing to increasing. Okay, so if you want to think about it like you're going downhill and you reach the bottom of the hill, that's like the min. So you're decreasing in altitude and then you start increasing in altitude. Okay, so there's a bottom. All right, so but this wants us to identify intervals. Okay, so the way I'm going to do this is I'm going to put decreasing and then a little colon, and then I'm going to put increasing and then a little colon. So remember, the intervals that you state are the x intervals. Okay, so this vertex is -1, -4. Okay, so at this -1 right here, this is where the graph goes from decreasing to increasing. Okay, so as far as the x interval goes, this graph keeps going on. So we're talking -infinity up to -1. It's decreasing. Now -infinity, always -infinity and positive infinity, they always get a parenthesis. And it's going up to -1, and we do not include the -1. Okay, because at -1 exactly, the graph is no longer decreasing. Okay, so this is our interval upon which the graph is decreasing. Now increasing happens right after the decreasing on this one. Okay, so we start at -1 on the increasing, and we go to positive, x is going out to positive infinity. So, and there is no place on the graph where it's constant. So use the graph to identify intervals on which the function is increasing, decreasing, or constant. And that is what we did. We used the graph to find where the graph was decreasing, increasing, and there was nowhere where it's constant. So that one's done. Now this one's a little different of a graph. Very little information given, but we can still give the intervals where it's decreasing, increasing, or constant. So even though this is going down, okay, as a graph, if you follow this graph, the y values, or f of x values, are increasing right there, right? So we consider that increasing. So we have a part where it's increasing. And then once we get here, it goes straight across. So the y values are neither increasing or decreasing, they're actually constant. So on this one, we don't have anywhere where the graph is actually decreasing. We have an increase and then a constant. Okay? So increasing, since this has an arrow on it, we have to say -infinity. Up to, remember, x intervals. Use your x. Okay? So don't say -2 for this. It's -1. Up to -1, we don't include the -1, just like over there. It's constant from -1 to positive infinity. Okay, so those are the two intervals where the graph is increasing and constant. Okay, I hope you understand that. Thank you.